Okay, in the last two sections of elimination, we looked at if the variables are already lined up, and you can eliminate by adding or subtracting a variable, do so, or you have to line up the variables. So let's do this one. 2x minus 3y equals 2. And off to the right, x plus 2y equals 8. Okay, so the variables are already lined up. We have x comma y equals number, so that's good. We're lined up. But now think, is 2x plus or minus x 0? No. Is negative 3y plus or minus 2y 0? No. So we have to do what's called multiply one of the equations by something. So I'm going to rewrite the equation on the right. X plus 2y equals 8. And I want to get it to have a 2x like the equation on the left. So it's an x right now. I have to multiply the whole equation by 2 and distribute the 2 in. 2 times x is 2x. 2 times positive 2y is positive 4y equals 8 times 2 is 16. Working on the equation off to the right. Now, top left, we have 2x in front and we have 2x in front. So we're ready to put the equations on top of each other. Now, it would be too messy to do it where it is. So I'm going to move it a line down. 2x minus 3y equals 2. And taking this equation and putting it below it. 2x plus 4y equals 16 over minus, let's minus. Brackets around the equation on the bottom. We're going to minus because 2x minus 2x is 0. So we don't do that calculation. Now we have negative 3y minus positive 4y, negative 7y. Do that calculation off to the right if it's difficult. 2 minus 16 is going to be equal to negative 14. Divide both sides by negative 7. And we have y equals positive 2. Circle your answer. Now put in the easier of the two equations. Well, this is a manipulated equation. So we should put it back into the original. I'm going to put it directly below. X plus 2y equals 8. Carefully taking our y value that we just figured out off to the left and carefully substituting it in for the variable that it represents, y. And cleaning it up. 2 times 2 is 4. The right-hand side is still 8. Minus 4 from both sides. X equals 8 minus 4 is 4. Circle it. Immediately state your answer. X comma y, excuse me, not x. Erase that. 4 comma 2. Circle your answer twice. Found the intersection. I forgot to probably check my answer. Did I check my answer on the last one? No, I didn't. Oh my gosh, take your answer. Put it back into both. Make sure it works. Last chapter. Take it. Put it into both. It has to work in both. Okay, so that's multiply. You can multiply in big blue one of the equations by a certain number. In this case, it was multiplying the equation on the right by 2. So, big blue top left, we have a 2x in front of both of them. Then we can put the equation and then add or subtract. In this case, subtract them. It turns out that big blue, when we multiplied the equation by 2, it's always going to be some sort of a lowest common denominator, common multiple principle. So if you're thinking you might have to multiply both equations by a number, figure out what the lowest common multiple numbers between both equations are, and then multiply the opposite by whatever needs to be to get to be that lowest common multiple, then put them on top of each other and add or subtract them. The example down below is exactly the same example above. Multiply. If you have a fraction or a decimal, turn them into fractions. And then just start by cleaning one up by multiplying both sides by the LCD. That method is learned better back in grade 8 equations. multiply both sides by the LCD, clearing up a complex fraction, and then it turned out that it was just ready to be put underneath the other one, and then we subtracted them, got the intersection, crazy decimals. All right, so that's all of the options for elimination. Line them up, add or subtract them, possibly multiply one or both equations by a number to get the same coefficient of the same variable so they can add or subtract and eliminate a variable. Obviously, substitute that back into the other equation or whichever, the easier of them, write down the intersection point and put them back into both equations to check your answer, like there's a whole section in the last chapter. Substitution and elimination.